इस वीडियो में मैं ऑप्टिक्स के वो क्वेश्चन सॉल्व कर रहा हूँ जो IIT 2019 में आए थे। तो फर्स्ट क्वेश्चन है, ए कन्वेक्स लेंस इज पुट 10 centimeter from a light source and it makes a sharp image on a screen kept 10 centimeter from the lens. Now a glass block जिसका refractive index है 1.5 of 1.5 centimeter thickness is placed in contact with the light source. To get the sharp image again, the screen is shifted by a distance d, then d is. This image can be, the diagram can be like this. This is a lens. This is object. This is at 10 centimeter from this. That is, this is A. This is object. You can say O. And here the screen is placed. That means this image is obtained. This image is obtained at this point. If this is 10, this is 10, then it is very much understood that this R is equal to 10 or 2F is equal to 10 or F equal to 5 centimeter. Now it is said that a glass slab is put here. It has thickness 1.5 centimeter. Mu is 1.5. That means this object will be shifted by the distance t minus t upon mu, that is 1.5 minus 1.5 divided by 1.5, that is 0.5 centimeter. So new distance will be, object का distance जो होगा that will be minus 9.5 centimeter. So according to relation 1 by V minus 1 by U is equal to 1 by F. So new V will be 1 by V is equal to 1 by F plus 1 by U, that is 1 by 5 minus, because this U is minus 9.5, that means I can say 10 by 95 or 2 by 19. So this will be approximately 9 by 95. If this is 95, that is V is equal to 95 by 9, that is 10.55 के राउंड आपके पास आएगा. So this will have to be shifted away. This will have to be shifted away by 0.55 centimeter. This option is D. Next question we will be doing. Two coherent sources produce waves of different intensities which interfere. After interference, the ratio of maximum intensity to the minimum intensity is 16. The intensity of the waves are in the ratio. So we will be doing this question from very basics. Basics, that means let amplitude of one of the wave is A1, second is A2, that means intensities are A1 square, A2 square, and combined intensity is A1 plus A2 maximum intensity upon A1 minus A2 minimum intensity, and this ratio is 16. So I can say that A1 plus A2 upon A1 minus A2 is equal to 4 by 1. I can divide this by A2 in the numerator and denominator. That means I can say that R plus 1 upon R minus 1 is equal to 4 upon 1. By cross multiplying this, you are getting 3R, because this is R plus 1, 4R minus 1, 3R equal to 5. That means R is equal to A1 by A2 is equal to 5 by 3. So we have to find the intensities of waves. So square करें, that is 25 is to 9. So this answer is P. Next question. Consider a tank made of glass, refractive index 1.5 with a thick bottom. It is filled with a liquid of refractive index mu. A student finds that irrespective of what the incident angle is for a beam of light entering the liquid. The light reflected from the liquid glass is never completely polarized. For this to happen, the minimum value of mu is. The diagram is given here like this. This is a glass liquid interface. This is liquid given here. This is glass, and light is incident, whatever angle of incidence, it does not matter. But here this is it will get deviated to some extent. It will get deviated. This is not equal to I. Let this angle is I. It is getting totally reflected here, and after that it will come out. Now, if this is not, as given the question, this is not completely polarized. If this is not completely polarized, that means this angle I is less than IP, because at IP it is completely polarized, but it is not polarized. That means I is less than IP. So tangent I is less than tangent IP. If tangent IP is here, that means this is, if this is 1.5, this is mu, that means refractive index of this medium with respect to this is 1.5 upon mu, that is 3 upon 2 mu. But if this is I, this is I, this is also I, and this must be critical angle. So this I for this critical angle, that is, you know that mu is equal to 1 upon sine I, critical angle. So sine I equal to 1 upon mu, and cos I you can find out root mu square minus 1 by mu. So by applying trigonometry, you can well calculate that this is 1 by mu square minus 1. So here we reach at this conclusion that 1 by root mu square minus 1, this becomes 1 by root mu square minus 1 equal to 3 by 2 mu. And if this is 3 by 2 mu, that means squaring both sides, this is less than, but squaring both sides, 1 by mu square minus 1 less than 9 by 4 mu square, or you can say that 4 mu square, that means here this is 5 mu square, this is, here it will be 9, or 5 mu square is greater than 9, or mu is greater than 3 upon root 5. That means if mu is greater than this, this is the minimum value. So this is all about this question. In a Young's double-slit experiment, the slits are placed 0.320 millimeter apart. Light of wavelength lambda equal to 500 nanometer is incident on the slits. The total number of bright fringes that are observed in the angular range minus 30 degree, less than theta, less than equal to 30 degree. In this question, two slits are given like this. You can consider that two slits are, these are the sources, and this width is 0.320 millimeter, that means 3.2 into 10 raised to the minus 4 meter. Here this is screen. So if we find, we have to find the number of fringes between, this is 30 degree, this is minus 30 degree. In this region you have to find total number of fringes. So first we can find the angular width. What is angular width here? If this is beta, this is capital D, that means angular width will be beta by capital D, that is theta equal to lambda by D, because we know that beta is equal to lambda D by small. This is a fringe width. So this lambda used here is 500 nanometer. So from here we can find theta, 500 into 10 raised power minus 9. Small d is 3.2 into 10 raised power minus 4. These are in radian. So if this is radian, we have to calculate this in degree, that means 180 upon pi. So here you get 5 into 10 raised to power minus 3, 3.2 into 180 upon pi degree. You have to find between 30 degree. For 30 degree, this much degree, for this much degree, 5 into 180 into 10 raised to power minus 3 upon 3.2 pi, this is equal to 1 for this much degree. So for 30 degree, this will be 3.2 pi into 10 raised to power 3, 5 into 180 into 30. So we can calculate from here. This is 36 and this can be cancelled here. This can be cancelled here too. That means approximately 5 to the 10. This will be 320. So 320 fringes are here, 320 fringes are here, and 1 is the center fringe. So answer is 641. Next question is, two planes are inclined to each other. Two planes are inclined to each other such that a ray of light incident on the first mirror M1 and parallel to the second mirror is finally reflected from the second mirror parallel to the first mirror. Angle between the two mirrors. That means consider the planes mirrors are like this, and one ray is coming parallel to M1. Let this is M1, this is M2, and this is coming parallel. And after reflection from here, it goes parallel to this M2. So we have to find theta. Now, if this is theta, that means this angle is also theta, corresponding angle, and this is 90 minus theta. If this is 90 minus theta, that means this angle is also theta. And similarly here, if this is theta, this goes parallel, this is theta, this is 90 minus theta, this is 90 minus, this is theta. That means 3 theta is equal to 180 degree, theta is equal to 60 degree, or simply this is equilateral triangle because the angles are equal, so angle will be 60 degree. Next question है, in a Young's double slit experiment with a slit separation 0.1 millimeter, one observes a bright fringe at an angle of 1 by 40 radian by using light of a wavelength lambda 1. A bright fringe is seen at the same angle when a light of lambda 2 is used. A bright fringe is seen at the same angle in the same setup. Given that lambda 1 and lambda 2 are in visible range 380 nanometer to 740 nanometer, their values are. Now, what is given in the question? In this question, slit separation is 0.1 mm. This is 0.1 mm. That means 10 raised to power minus 4 meter. And angle made by the fringe, bright fringe at the center is, this is 1 by 40 radian. This is 1 by 40 radian. And let this is N1 fringe, and wavelength used is lambda 1. So let us find this beta is equal to, again as we have done earlier, beta upon capital D, that is theta is equal to beta upon capital D is equal to lambda by small d, or theta is equal to N1 lambda 1 by d. So from here theta is equal to 1 by 40. N1 lambda 1 upon small d is 10 raised to power minus 4. So N1 lambda 1 is equal to 10 raised to power minus 4 by 40. So roughly we may calculate this as 20, not roughly, exact, this is 2500 into 10 raised to power minus 9, that is 2500 nanometer. This is N1 lambda 1, so lambda 1 is equal to divided by N1. Range is given to us 380 nanometer to 740 nanometer. So to find wavelength between this range it depends upon n1. If n1 is equal to minimum value is 4, that means this lambda 1 is 625 nanometer. Lambda 1 is 5, n1 is 5, this is 500. This is 6 and 3 is 6, that means 425. All these are possible values of wavelength for which the bright fringe can be obtained at this position. So out of the given option, A is correct, that is 625 and 500. The eye can be regarded as a single reflecting surface. The radius of curvature of this surface is equal to that of cornea, 7.8 millimeter. This surface separates two media of refracting indexes 1 and 1.34. Calculate the distance from the reflecting surface at which a parallel beam of light will come to focus. Now, what is given here? This is the construction of that glass that appears to be eyeglass. This is 1.34. This is 1.34. So we are considering this as 1.34. This complete is 1. This is 1 here. So this is a parallel beam of light is entering here. That means if this is parallel beam of light, so this will be, that means u is equal to infinity. U is equal to infinity, and radius of curvature is given to you, that is 7.8 mm, that is 10 raised to power minus 3 meter. So here you have to find where it will get focused. So we have to find V here. Relation is simple, as we have for spherical surfaces, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Here mu2, in which the image will be formed, that is 1 by 3/4, that is V, minus, this is 1 by infinity, this is mu2, that is 0.34 minus mu1, and this is 7.8 into 10 raised to power minus 3. This is again positive because R will be here, so distance will be measured in the direction of incident ray. So V can be find out like this: V is equal to 1.34 into 7.8 into 10 raised to power minus 3 upon 0.34. Approximately, if I want to cancel out this will be 3, this will be 4 पे cancel होगा. So approximately this is 7.5 into 4 is 3, so this is slightly greater than 3. So out of the options, this is 3.1, this is 30 into 10 raised to power minus 3 meter. So not 30, 31 के आसपास आएगा, और 32, that is 3.1 centimeter. This is option D. Next question. Here a plano convex lens is given, that is of refractive index mu1 and focal length f1. Plano convex lens. This is plano convex lens. And a plano concave lens. This is plano concave lens. This has focal length f1 and refractive index mu1, and this is this is focal length f2 and refractive index is mu2. For here, we can find 1 by f1 is equal to mu1 minus 1. This is 1 by r1. r1 is 0 minus, this is minus r. So mu1 minus 1 upon r, that is f1 is equal to r upon mu1 minus 1. And for this, 1 by f2 is equal to mu2 minus 1 this is infinity minus 1 by R2, F2 is equal to minus R2 upon mu 2 minus 1. But here this is given that F1 equal to 2F2. So we will be ignoring this negative sign because we have to just the relation F1 equal to the magnitude of F2 will be R2 by mu 2 minus 1, and this is not R2, this is R only. So R upon mu minus 1 equal to 2R upon mu 2 minus 1. That is mu 2 minus 1 equal to 2 mu 1 minus 2. That is mu 2 minus 2 mu 1 equal to minus 1, or 2 mu 1 minus mu 2 equal to 1. This will be the answer. That is B option is there. In a Young's double-slit experiment, the path difference at a certain point on the screen between two interfering waves is 1 by 8th of wavelength. The ratio of the intensity at this point to that at the center of a bright fringe is. Here in this question, you have to find the ratio of intensity. That means consider this as a double-slit experiment. This is center. That means there is no phase difference here. This let intensity at this point is I naught, and consider this point here where this path difference, this is lambda by 8, that is phase difference corresponds to pi by 4. So let's consider this is I. So we have to find I and I naught. I naught can be found out like this. I naught is equal to A square if A is the amplitude of each wave plus 2A square cos 0. That is, you can find out this as 4A square. And what is this I? I is equal to A square plus A square plus 2A square cos pi by 4. That is 2A square into 1 plus cos pi by 4 is 0.7. That is 2 into 1.7 A square. Now you can find the ratio between these two. You have to find I upon I naught. That is 2 into 1.7 A square upon 4A square. So this becomes 0.85. Next question is, an object is at a distance of 20 meter from a convex lens of focal length 0.3 meter. Lens forms an image of the object. If the object moves away from the lens at a speed 5 meter per second, the speed and direction of the image will be. First, let us draw a rough diagram in this question. This is lens. Consider this as an object at a distance 20 meter from lens. Focal length is 0.3 meter. And we know that 1 by V minus 1 by U equal to 1 by F. So to find the velocity of image, whereas velocity of object is given, velocity of object is given as equal to du by dt is equal to 5 meter per second. As it is taken away from the lens, so it will be negative because the incident direction is towards right and it is taken towards left, so this will be minus. From here we can find minus dv by v square plus du by u square equal to 0 since f is constant. So here dv is equal to minus v square by u square du, that is dt dt. You can find dv by dt knowing this v square by u square, minus is cancelled with this. Now what is v upon u? V upon u can be find out from here and this will come out. if you divide it by u by f, this is 1, this is u by y, by taking the reciprocal, you will be getting f upon this is f upon f plus u square, and du by dt is minus 5. So roughly we take f is equal to 0.3, and here 20 plus 0.3, it will not much difference. 20.3 is, this is negligible as compared to this, so we can take 20. This is cancelled, this is 100, that is square into minus 5. That means you are getting here 9 into 5, that is 45 into 10 is power minus 4. This is 20, that is divided by 4 with minus sign. That is you can say minus approximately 1.1 something into 10 raised to power minus 3 meter per second. This negative sign also shows that motion is against this, against the direction of incident ray. So motion is, that is towards the lens, towards the lens. Next question. A monochromatic light is incident at a certain angle on an equilateral triangular prism and suffers minimum deviation. If the refractive index of the material of the medium is √3, then the angle of incidence is. That means equilateral prism is given to you. That means this angle is 60 degree. That is 60 degree. That is equal to A. Now it suffers minimum deviation. Incident ray suffers a minimum deviation. That means if this is normal, this is incident ray. In case of minimum deviation, this line, refractive line, is always parallel to the base. This I, this E, these are also equal. So we have to find the angle of incidence. If this is 60, this is also 60. This is also 60. And you know that mu is equal to sine I minus sine R. And this is sine I. R in case of minimum deviation, because this A equal to R1 plus R2, these two are equal, that is 2R, R equal to A by 2, that is sine 30. Since this is 60 by 2, that is 30 degree. And mu is also given as √3. √3 is equal to sine I by 1 by 2. So this implies sine I is equal to √3 by 2, that is I is equal to 60 degree. So refractive index is, so incident angle is 60 degree. Now next question. In a double-slit experiment, green light 5303 angstrom falls on a double slit having a separation of 19.44 micrometer and a width of 4.05 micrometer. Number of bright fringes between the first and the second diffraction minima is. Let us again draw a diagram. Here this is Young's double-slit experiment, but here both the processes are going simultaneously. Due to this width of the slit, we are getting diffraction pattern, and due to these two slits, we are getting interference fringes. So against this, you are getting, this is central maxima, this is first minima, this is the second minima. That means in this width, we have to find in this width how many fringes are there, interference fringes कितने, एक ये हो गया, एक ये हो गया, like this we have to find. And for this we have beta is equal to lambda by d. This is for diffraction, and for interference again lambda by d dash. So this is the width of this thing between first minima and second minima. if we are taking the width of this slit. If we are taking the width of this slit, then we are finding this one. This is the width of interference fringes. So number of fringes can be find out. Beta d upon beta I interference fringes, that is d dash upon d. This is d dash upon d. What is d dash in case of this is 19.44 micrometer upon second is 4.05 micrometer, and complete division, it does not cutting it at 5, so this is 4 will be the complete bright fringes within this distance. So this answer is 4. Next question is, what is the position and nature of image formed by a lens combination as shown in figure? F1 and F2 are focal lengths. So here what is given to us, the figure is like this. This is a convex lens at a distance of at a distance of 2 centimeter. A concave lens is placed. Here object is placed. This is 20 centimeter. F1 is given to 5 centimeter and F2 is also 5 centimeter. You have to find the final position of image. Let us apply here. 1 by V minus 1 by U is equal to 1 by F. So to find 1 by V, that is position of image, is equal to 1 by F plus 1 by U. 1 by F is 1 by 5. This will be taken as positive, and minus 20, 1 by 20. So this comes 3 by 20 centimeter. That is V is equal to 20 by 3 centimeter. That means image is forming like just here. Then the distance between these two will be, this is 2 centimeter, that is 20 by 3 minus 2, 14 by 3 centimeter. But again we are taking distance in this direction. This will be this will be distance in this. That means again applying mirror lens formula for this, that is 1 by V minus 1 by U is equal to 1 by F. You have to find image. Minus 1 by U is 3 by, this is U. This is the value of U. So this will be 3 by 14. Since distance is taken in this direction, this is the virtual object in this direction, from this to this towards left, so it will be taken as positive. 3 by 14 equal to 1 by F. F in this case is negative, minus 1 by 5. So 1 by V is equal to minus 1 by 5 plus 3 by 14. If this is minus 1 by 5 plus 3 by 14, so this will be you can say that 1 by 70. That is V is equal to 70 centimeter. This is positive, so this will be here. So this is real. Real image will be obtained at a distance of 70 centimeter from this lens. So option is D. Next question is, a point source of light S is placed at a distance L in front of the center of a plane mirror of width D, which is hanging vertically on a wall. A man walks in front of the mirror along a line parallel to the mirror at a distance 2L as shown below, the distance over which the man can see the image. So this question is like this. Okay, here this is mirror. source is here at a distance L from this, and a man is moving here at a distance again L, or this is 2L from this. So this distance is D, the length of the mirror is D. Man is moving here, so to what distance it will move to such that it will be having complete image in that. So if he gets the image of this source, this man has to see the image of this source in the mirror. The image of this source is lying here, and light travels in straight line. So when a man reaches here such that he can see the image of this object, he can see the image of this object, that means this ray is falling on this and image is seen here. Similarly, image of this source in this mirror can be seen up till this point, So by applying by seeing this triangle and this triangle, these two triangles are similar. If this is D by 2 and this is X, you know that this is L and this is 3L. So D by 2 upon L equal to X upon 3L. D by 2 upon L is equal to X upon 3L. So X is equal to 3 by 2D. Therefore this is X, this is X. Total distance will be 2X, that is 3D. A light wave is incident normally on a glass slab of refractive index 1.5. If 4% of light gets reflected and amplitude of the electric field of the incident light is 30 volt per meter, then the amplitude of the electric field for the wave propagating in the glass medium will be. This question can be find out using electromagnetic wave, or in the simpler way we can consider that as given here, a light is entering into the medium, and if a light is entering into the medium, let this is mu, that means intensity of light will be affected by I is equal to I naught by mu. And what is I naught here? The amplitude of light, amplitude of electric field is given as 30 volt per meter. So I naught may be considered as proportional to, you can say, 900, because I naught is proportional to amplitude square. So here I will be equal to 900 upon mu, and it is getting that 4% is reflected and 96% is entering into this, that means into 96 by 100. So amplitude will be equal to square root of I, that is square root of 900 into 96 by 100 into 1.5. 1.5, that means this is 600. 6 into 96, that means this will be 24 volt per meter. This is the amplitude of the refracted wave. Next question is, a plano-convex lens, focal length f2 and refractive index mu2, radius curvature r, fits exactly into a plane concave lens, focal length f1, refractive index mu1, radius curvature r. Their plane surfaces are parallel to each other, then the focal length of the combination will be. Focal length of the combination, that means we can find out like this. This is plano-convex. Radius curvature is this as this is mu2, focal length is f2, radius curvature is r, and this is a plano concave lens. This is mu1, this is f1, radius curvature is r. So combined focal length, let this is 1 by f is equal to 1 by f1 plus 1 by f2. What is 1 by f1? That is mu2 minus 1, 1 by infinity minus 1 by minus r plus mu1 minus 1. This is minus 1 by r minus 1 by infinity. So here you are getting this mu2 minus 1. This will be 0, that is 1 by r minus mu1 minus 1. So here you are getting mu2 minus mu1 by r. So f is equal to r upon mu2 minus mu1. Formation of real image using bioconvex lens is shown below. The image in the figure is given like this. This is 2f, this is f, here this is lens, this is f, this is 2f, screen is placed here, object is placed here, image of this object is getting on the screen here at this point. And if this whole setup is immersed in water, then what will be the position of image, whether it is available on the screen or not? It will not be available on the screen, because its f will change. Why f will change? Because if it is immersed in water, the refractive index of this glass with respect to medium, with respect to water, will change. And if it changes, its focal length changes. If its focal length changes, image will no longer be obtained on the screen. So it will disappear. 18th. Consider a Young's double-slit experiment as shown in figure. What should be the slit separation in terms of wavelength lambda such that the first minima occurs directly in front of the slit S1. This is S1, this is S2, this distance is D, and it is said that first minima is obtained directly opposite this. So understood है कि this is d by 2 and this distance is given as 2d. That means first minima is obtained here. If this is first minima, that means this path difference is lambda by 2. And what is this lambda by 2? That means from here we have to find the slit separation in terms of wavelength. Lambda, we have to find the value of d in terms of lambda. Then we can say that the path difference here, this is 2d, and this distance, let this is p. So path difference is lambda by 2 is equal to S2p minus S1p. What is S2p now? S2p is, this is 2d and this is d. That means 2d square plus d square under root minus S1p is 2d. So you are getting here root of 5d minus 2d, that is root of 5 minus 2d. This is lambda by 2, so d will be equal to lambda by 2 root of 5 minus 2. So this is the answer. So this is all about this optics, question from optics which were appeared in IIT JEE 2019, that was held in January. Maybe if any question is left by mistake, so those will be covered in the final video. All the questions, all the remaining questions will be discussed there. Next video will be from modern physics. All the questions from modern physics, those were appeared in IIT 2019, held in January. Thank you.